Okay, here we are on 10.6 and page 2 of the notes. And at the top here, just on pages 643 and 644, some reminders what a definition of a relation is, and that's any relationship between x and y, a set of domain that produces a range. That's a relation. Function, however, is that special relationship where no two ordered pairs of a function can have the same first component but different second components, which is a fancy way of saying you can't have an x give you two different y values. You can't input the same thing and then get two different things out. A function just does one job. Put an x in, get an x out. Put a different x in, get a y out. They don't have to be different y's, but they do have to be different x's. When you put them in, you can't get the same y out from or you can't get the same, you can't put in the same x and get two different y values. Sorry, I botched that just a little bit. Oh. Okay, so we're going to move just down the page here and look at some examples of what you can do with functions. You can do everything that we've been doing algebraically all along. We're just getting used to this terminology of a function. So here's the instructions. It says to evaluate each function at the given values, which is a fancy way to say we're just going to substitute an x value in and get our y value out. Okay? But we're just learning about the notation now. So what we used to see is that we used to see y equals. What we're used to seeing is y equals x squared minus 4x plus 5. Put in an x, get a y value out. Good, done, everything's taken care of. Now this is called function notation. So now we're saying that x has a job to do here. So this is the function h. Typically f, g, h, those are the main letters that are used for function, but really anything can be a function. So h of x, what that means is that when you put in a value for x, something happens to it. In this case, it gets squared, multiplied by 4, and then subtracted, then 5 gets added into it. So something happens to x, and you get an output. H of x represents the y. So x is what goes in, h of x is what comes out. So h of x is equal to our y value. That's what you can relate it to. H of x is just like our y. Okay? So until it becomes more familiar, just imagine that h of x is really that y value that we're used to seeing there. Okay? And so when you see something like this where it says find h of 4, we're not multiplying by 4. Okay? We're saying take that function h, that certain job, like let's say its job is to, oh goodness, what's something that starts with h? Heavy lifting, okay? So the function here is to do some heavy lifting, h for heavy lifting. So you're going to put 4 into the function machine for heavy lifting, you're going to get an answer out. So the 4 is our x value, and we're going to put it in everywhere we see x. And so what you can do is say, okay, well, h of 4 means that we're going to take our x squared and our minus 4x and our plus 5, and we're going to take that value of 4 and we're going to put it in everywhere we see the x value. Okay, so what happens, what's the heavy lifting that happens to 4? Well, we're about to find out here. 4 squared is 16, minus 4 times 4, which is minus 16, and then plus 5. The 16s cancel each other out, and you get 5. So our function value, when you put in 4, h of 4 gives you 5. So h of 4 gives you 5. And the way you say that is h of 4 equals 5. That's the way you read that. It's not h times 4. This is function notation. I told you it was going to kind of mess with your mind a little bit. It will get easier as you get used to it. Okay? So same type of thing here. h of negative 4. What does that mean? Well, we're going to take that negative 4 and put it in everywhere we see x. So what is happening to negative 4? We want to find out. So when we put it in to x squared minus 4x plus 5, here's our negative 4, and it's going to go in everywhere we see the x. So what's happening to negative 4? What's the function of negative 4? What happens when you put it into this machine? What will our output be when it comes out? Well, negative 4 squared is a positive 16. Negative 4 times negative 4 is a positive 16. And then you've got the plus 5. 16 and 16 is 32. 32 plus 5 is 37. So h of negative 4 equals 37. And the way you'd say that is h of negative 4 equals positive 37. Okay? What happens when you try to find h of 0? Well, again, the 0 goes in. Here's our h of x is equal to x squared minus 4x plus 5. So, okay, I'm going to put 0 in for x. So I want to find out what happens when we throw x into the machine. So here it's kind of like the, I'll probably get this analogy wrong here, but the batter that's next to the line to hit in baseball, they have a certain spot where they stand. They're not in the dugout, they're not in the line of play, but they have a little, is it the batter's box? Gosh, I'm horrible, I don't know baseball good enough, but it's the first thing that came to mind. It's like, okay, here he is, and now we're going to put him into play. So it's kind of hanging out here. What's going to happen to 0? Put it in. 0 squared minus 4 times 0 plus 5. So say, okay, h of 0, 0 squared, 4 times 0, 0, 0, add the 5, you just get 5. So h of 0 equals 5. That's how you read it in function notation. H of 0 equals 5. So you put 0 into this function over here, and you get 5. Now, these can all be called function because they're telling us that they are. If we had to test it, we would use our arrow method or our other methods that are going to come up later. But for now, if they tell us they are functions, then we know that they have this, that they pass the arrow test, that when you put an x in, you are going to get one y value out. You're not going to be able to go all kinds of different directions. So you're going to get one answer when you put your x's in. And that's the definition of what a function is. Okay, so on number 24 then, here's another function, f. F of x, the function of x here is we're going to take x and we're going to divide by the absolute value of x. So the way to read that is f of x, or the function of x. And these lines here are absolute value. Hopefully you recall that from your Math 60 in earlier days. So f of 5, what that means is we're going to take our function here, and we're going to put 5 in everywhere we see x. So we just have 5 on the top, absolute value of 5, just makes everything positive. It's just a measurable distance back to 0. So it becomes 5 over 5, it becomes 1. So f of 5 equals 1 is what we'd say there. F of 5 equals 1. And the function of 5, when you put it into this formula, this equation, you get a value of 1 out. Okay, same thing with f of negative 5. It would look like this. F of negative 5, we're going to put this into our formula here. So we've got negative 5 sitting there. It's going to go everywhere you saw the x originally. Negative 5 on top. Absolute value of negative 5 is going to be positive 5. Negative 5 divided by positive 5 is negative 1. So what we'd say is f of 5, f of negative 5 equals 1. Okay? Don't make this section harder than it needs to be. Sometimes it feels like, oh, the last section of the year it's going to be this big culmination of everything. No, functions, pretty nice way to end up. Just a little bit of new vocabulary, a little bit of new concept here. Please don't make this harder than it is. Just let it kind of smooth itself over in your brain. Let your brain get used to this new vocabulary, new concept. And don't make the problem super hard. As I say that, and you look at maybe number 22, the one I'm going to ask you to try, you go, holy cow, there's all kinds of things going on. Radicals, you've got the variable inside, all these things. Don't panic. Deep cleansing breath here. What we've done in these other examples is we took the number, plugged it in everywhere you see the variable. So f of r here means that the variable we're plugging in for is r. Our result is the f, the function, the output. The function of r is to go inside here, get subtracted from 25, have its square root taken, and then 6 will be taken away from that, and then you get your result. So that's the function of r. That's what happens to r when you put a value in. So we've just got f of 16, that's what you put in. See what happens. F of negative 24, that's what you put in. See what happens. So try those. We'll come back in just a minute. Pause the video, I should say, and then come back when you've got those done. So when you plug in f of 16, you should get an answer of negative 3. And when you plug in f of negative 24, you should get an answer of positive 1. And again, it's just learning the new terminology here. F of negative 24 is 1, or equals 1.